Hi guys, let's do validate stack sequences. So we're given two integer arrays pushed and popped, each with distinct values, and they want us to return true if this could have been the result of a sequence of push and pop operations on an initially empty stack, or false otherwise. So we're given these two examples, where in example 1 we return true because if we have a stack, then we could have we could have pushed in and popped in this order. So we push 1 from here, we push 2 from here, we push 3 from index 2, we push 4 from index 3, and then we pop 4, and then we push 5 from index 4, and then we pop the 5. So far we've popped the 4, we pop the 5, then we pop the 3, then we pop the 2, and then we pop the 1, and our stack ends up empty, so we return true. And in example 2, we return false because this is not possible. So we can push 1, then we push 2, because we check every time we were checking here and popped to see if this number matches up with the element at the top of the stack, and so far it doesn't. So we keep pushing until we reach this number. So we can push 1, 2, 3, and 4, and then this 4 matches up with 4 here, so we pop 4, then since 3 is at the top of our stack, which matches 3 here, we pop 3, and then 5 does not match up with 2, so then we continue where we left off at this 4. So then our next number is 5, so we can push 5, and then we can pop 5 because 5 is next here, these match. So we pop 5, and then we need to pop a 1, but we don't have a 1 at the top of our stack, so this doesn't work, so we have to return false for example 2. So for this one, we can use a stack and 2 pointers because we need our stack to push and pop to check if they're push and poppable, and then we need a pointer for each array to keep track of what index we are at, since we're not just looping through like linearly or like all at once or anything. We might need to stop and continue in the middle depending on how the numbers match up. So we're going to initialize our stack of integers, and then we're going to want a pointer for popped. So I'll just name it pop and start it at 0. And then the pointer for push, I'm going to just do it in a for loop because we're going to stop once we reach the end of pushed, right? Because we need to keep pushing until we reach the end of this. This we're going to basically go through linearly, but for popped, we might stop at an index for quite a while. So for int push is 0, push is less than push dot length, push plus plus, and then we are going to, so we're going to push each element as we go. So we're going to push each number from this array, and then until we reach a number where the top of the stack is equal to the number that we are at in popped. So then we're going to keep popping elements until they don't match up anymore. So we're going to have a while loop. So while our stack is not empty, because that means there's nothing to even be able to pop, and we need to make sure that pop is less than pop.length so we don't get an out of bounds, and then also when these numbers are the same. So stack.peak equals popped at pop, so we need to make sure those numbers are the same. So while this is the case, we're going to keep popping elements from the top of our stack, and then we're going to increment our pop pointer through popped every time we pop it, so we move on to the next one each time. So then pop plus plus, and then we're going to keep doing this for every element until we reach the end of popped. There's nothing else to pop, or we reach a number where the number matches up or doesn't match up with this number anymore, so then we'll just continue to push and go into our next iteration of the loop. Or our stack is empty, so there's nothing else that we can pop, so we either continue through push and keep pushing things, or if we are at the end of here, then we'll just exit out. So once we exit out, then we're going to want to return if our pop counter or pointer, I guess, is equal to the length of popped. And that is because we need to check that we actually were able to pop every single element successfully. And so if we did, then that means we will have reached the end of the array. So let's, oh my gosh, sorry guys. Okay. Okay, I don't know why I keep making mistakes recently, sorry about that. So our time complexity is going to be O of n, where n is the number of elements to push and pop, because our pushed and our popped arrays are always going to be the same length, because if they're not, then obviously we can't possibly do all of those push and pop operations, because if you push it, then you're going to have to pop the same element, right? Otherwise it's going to be false. So yeah, and then if we think about it, so for every single element in the array, we are doing it 2 different operations on it. We are pushing it onto the stack, and then we're popping that same element off of the stack. So that's 2 different operations, but each one is O of n. So it's basically O of 2n, because it's O of n plus n. But then we simplify that to just O of n. It's kind of confusing because we have a while loop inside of a for loop, so you would think it's like O of n squared, but it's actually not. Because we're technically just doing 2 operations on each element rather than like, you know, looping through like n squared times or anything like that. So then our space complexity is also O of n, because number of elements in pushed / popped, because these are the same elements just in a different order. And that is because we have our stack as our data structure here, and we are adding every element onto the stack and popping it. So that's O of n to add them all. And then even though we pop them all after, it's still O of n. So that's it for this problem. Thank you guys for watching. Bye.